Pay careful attention to bounds of fractional quantities or dividing calculations. The lower bound of a over b equals the lower bound of a divided by the upper bound for b. And the upper bound of a over b equals the upper bound of a divided by the lower bound of b, when a and b are positive numbers. In question 1, a rectangle is 14 centimetres long and 11 centimetres wide, and each measurement is given to the nearest centimetre. We need to find the upper and lower bounds for the area of the rectangle. The diagram may help visualise the situation. The solid blue rectangle is 11 centimetres by 14 centimetres, and inside it the dotted black rectangle measures 10.5 centimetres by 13.5 centimetres, and actually surrounding both of these rectangles is the red dotted rectangle, which measures 11.5 centimetres by 14.5 centimetres. These would represent the original rectangle, but remember its measurements are only given to the nearest centimetre, so we have a lower bound rectangle and an upper bound rectangle. So the area for the upper bound is equal to the length of the upper bound multiplied by the width of the upper bound, so this equals 14.5 times 11.5, which is 166.75 centimetres squared, and the area for the lower bound is equal to the length of the lower bound multiplied by the width of the lower bound, and this equals 13.5 times 10.5, which equals 141.75 centimetres squared. This is the lower bound for the area of the rectangle. In question 2, a equals b over the square root of c, and b is equal to 1.36 correct to 3 significant figures, and c equals 5.721 correct to 4 significant figures. And in part A we need to find the upper and lower bounds for a. Now a is a fractional quantity, so the upper bound for a is equal to the upper bound for b divided by the square root of the lower bound for c. So this equals 1.365 over the square root of 5.7205, and this equals 0.5707102287. In a similar way, the lower bound for a is equal to the lower bound for b divided by the square root of the upper bound for c, and this equals 1.355 over the square root of 5.7215, and this gives 0.5664796,905. Now in part B it says, hence give the value of a to a suitable degree of accuracy, giving a reason for our answer. Now if we look at the two values for the upper bound and lower bound for a, they actually agree to 2 decimal places. In other words, they both round to the same value to 2 decimal places. So a equals 0.57 because the bounds agree to 2 decimal places.